Okay, so for our next assignment, hopefully you've already gone through the balancing charges for chemical nomenclature. In ionic compounds, we have negatively and positively charged anions and cations, which come together to form a neutral species. However many electrons were given up by the cation has to be as many electrons were gained by the anion. Another way to think of this is the sum of the charges must sum to zero. They must add to zero. So when you mix magnesium and chloride, because magnesium is 2 plus, you're going to need two chlorines that are both 1 minus, so two of the chlorines, so that the charges balance to zero. And when iron loses 3 electrons and is iron 3 plus, you'll need two iron 3 pluses with 3 oxides, which are always O2 minus, to have 6 plus and 6 minus charges, which will sum to zero. So in this following assignment, we're going to take ionic pairs and find out what the formula would be for them, making sure that we use parentheses when necessary to indicate multiple polyatomic ions, and make sure that the charges always sum to zero. All right. So sodium 1 plus and sulfide 2 minus, we're going to have 1 plus and 2 minus, so we'll need 2 plus to balance out with our 2 minus of our sulfide. As a result, we're going to need another Na plus, so 2 of these. So our species would be Na2, because we'll need 2 sodiums and 1 S, sodium sulfide. So beryllium 2 plus and iodide 1 minus. So we're going to need another I minus to have 2 plus for the cations and 2 minus so that the charges sum to zero. So BeI2. Calcium 2 plus and sulfide 2 minus. Already we have 2 plus, 2 lost electrons, 2 gained electrons. So our charges already sum to zero. So we just put them together, CaS. All right, so now we have our first polyatomic anion, phosphate, which is 3 minus, and potassium, which is 1 plus. So we're going to need 3 plus to balance our 3 minus charge. So we'll need 2 more K pluses to fill that order. So our formula would be K3PO4. 1 phosphate, 3 potassiums. Mg2 plus, Cl minus. So if we've lost 2 electrons, we're going to need to gain 2 electrons. So we would need a second chlorine over here for that to be true. So our formula would be MgCl2. 2 chlorines for a 2 minus charge to balance out the 2 plus charge. Okay, aluminum 3 plus, carbonate 2 minus, so 2 minus and 3 plus. The least common denominator for these numbers is 6. It's the 3-2-2-3 relationship. And so we are going to have 6 plus equals 6 minus by having 2 aluminum 3 pluses and 3 carbonates, which each have a 2 minus. Then we have 2, 4, 6, negative 6, 3, 6, positive 6. So our charges sum to zero. And so our formula will be Al2, two aluminums, and then we need 3 of these carbonates. And so we want to make sure that we don't put CO33. That would mean 33 oxygens. That makes no sense. What we want to say is that we want 3 carbonates. So here we'll use the parentheses and go CO3, close parentheses, and we need 3 of them. So 2 aluminums and 3 carbonates to have our -6 and +6 charges sum to 0. And this is our compounds formula. Okay, Sr2 plus and OH minus. So we have a 2 plus for our strontium. So we're going to need 2 minus over here. We have 1 minus for each hydroxide. So we'll need a second hydroxide, 2 of them. So we have our 2 plus and our 2 minus. So strontium. And because we want both 2 oxygens and 2 hydrogens, 2 hydroxides, we're going to use the parenthesis and put our polyatomic in there. And then say we need 2 1 minus hydroxides to balance out the charge of our 2 plus strontium. So this is our compounds formula. All right, iron 3 plus and cyanide, which is 1 minus. So we're going to have 3 plus, which needs to be canceled with 3 minus. So that means that we're going to need 1, 2 more, 3 total cyanides for 3 minus charge to balance out with our 3 plus. So that will make a compound Fe. And since we want 3 cyanides, we wouldn't want to put CN3. That would be 1 carbon and 3 nitrogens. What we're asking for is 3 carbons and 3 nitrogens. And so we're going to put the parentheses, CN, our cyanide, and 3 of them. So this would be iron 3 cyanide. Cu2 plus and O2 minus. So not much to do here because we have 2 plus and 2 minus. And so copper 2 oxide is just CuO. All right, so we have hydrogen phosphate and silver. Silver's always 1 plus. Hydrogen phosphate's 2 minus. So we're going to need 2 plus to cancel those out. So we're going to need another Ag. Silver again is always 1 plus, so 2 of them total. And so those will be 2 plus and 2 minus, sum to 0. We should have Ag2 HPO4. Zinc 2 plus and nitride 3 minus. So again, we have 2 and 3. The least common denominator will be 6. So we're going to end up needing a 6 plus to cancel with a 6 minus. To achieve that, we can have 2 nitrides, each with a 3 minus, be 6 minus total, and we'll need 3 zincs that are 2 plus each to be 6 plus total. And therefore, our compound formula will be ZN3N2. Lead, when it's lost 4 electrons, is lead 4 plus. When we want to combine it with acetate, which is C2H3O2 1 minus, well, we'll need 4 of them to have 4 plus equal 4 minus. So I'll just say this times 4 so that I don't have to write it so many times, but hopefully after so many examples, we get the idea. So we'll need 4 acetates altogether to counter the 1 lead 4+. So our compound formula will be lead Pb, open parentheses, because we want the acetate 4 times. So C2H3O2, and we want 4 of them. So altogether, there is 8 carbons, there's 12 hydrogens, there's 8 oxygens in the 4 acetates, which counter the 1 lead 4+. Lithium and nitrate. Lithium is always 1+ as an alkali metal, and nitrate is always 1-. So 1 and 1, they're already balanced. And we just put in the lithium, nitrate, no parentheses needed. Aluminum and fluoride. Aluminum is 3+, and fluoride is 1-. We're going to need a 3- total to balance out with our 3+ charge. So we'll need 2 more fluorides to get 3- total. So we'll have aluminum. Oops, we all make mistakes. No need for parentheses here because it's not a polyatomic. So I'll just put AlF3. Only need to use the parentheses when we have a polyatomic and we're trying to capture all of the atoms in the molecule multiple times. Like as in the case of carbonate and nickel 3+. When nickel loses 3 electrons, it becomes nickel 3+. And when we combine it with carbonate, we're going to have a 2- and a 3+ relationship. Least common denominator, 6, 3, 2, 2, 3. Going to get used to that pattern. Is going to be 6+ will cancel out with 6-. So again, we'll need 2 nickels that are 3+ each, and 3 carbonates, which are 2-. And so referencing the mistake I made on the previous slide, where in that case I didn't need the parentheses because I just had fluoride, 1 element as an anion. Now I have a polyatomic anion and I need 3 of them. And so in this case, I'm going to need to use parentheses around the carbonate to say that I need 3 carbonates. I don't need parentheses for the nickel. It's just its own element, even though it has 2 letters in its symbol. And we want 2 of them, 2 of the single element nickel 3+, and we'll need 3 of the polyatomic ion carbonate, CO3 2-, and we'll need 3 of them. So this species, Ni2CO3, is nickel 3 carbonate. All right, well, that's the end of our balancing charges. So hopefully you got an idea of what it means to balance the number of ions so that the charges sum to 0. Thank you so much for your attention.